Hello, water managers and swims users. I'm Russell Errett with the Water Management Systems Division out of the Hydrologic Engineering Center, and I'm covering swims implementation, and we're using St. Louis District as the example of how swims can be implemented in an office. So this is the seventh part and final part of a multi-part series on this presentation. So if you want to see the previous parts, check them out in the playlist. We have covered the St. Louis District overview. We've done a deep dive on how SWIMS has been implemented and set up into water management operations within the St. Louis District. We've gone over specific applications of SWIMS and how it was used during flood operations and other applications within the St. Louis District. And then we've also gone through how we've evaluated SWIMS forecasts and performance as compared to the legacy process, and kind of how we evaluate performance and improvements that can be done going forward. And so the final thing I would like to talk about in this part is another SWIMS usage, and that would be how we use SWIMS for flood damages reduced, typically done after a flood event, and most commonly in St. Louis done at the end of the year after all the flooding and everything has been done for the water year or the fiscal year. So flood damage is reduced in St. Louis. You can do this in your office either after a flood event, after everything's settled down. St. Louis generally does this all at the end of the year after the full process. There's a lot of different reasons why, and I can get into the weeds on the reasons why it's waited until the end of the year, but it's always been done towards the end of the fiscal year. We start doing the data validation and start doing the flood damage reduced on the tributaries, and then the Mississippi's generally last, and it's not done until later in basically the winter towards the end of the calendar year. So let's talk about the legacy method, the old method that was done for water management. This is probably not too dissimilar to any other office that would have done this. And so water control would provide a with and without reservoir stages, and we would provide that to the economist. And the way that was done is there was like a legacy routing model, if you will. So like a DSS math, used to be a DOS program. I was involved with migrating it from the DOS program to a DSS math script, and then it ended up being in the CAVI as a CAVI script, and now we've moved forward to a SWIMS modeling process. But I've gone through all the various permutations of this. But basically, it's just a routing model that's taking the observed data, which would be blue, so we're taking what actually flooded, and then we're routing inflows from the projects, and then basically saying, okay, if the reservoirs didn't exist, what would those river stages look like, which is routed to these locations, which we end up with red. And so what we would do is we would cherry pick anything that was above some threshold. So typically there's a line that says, oh, the economists will say this is where damages start to occur. Generally it's around flood stage. Surprisingly, at some locations it's actually several feet above flood stage. So it's just kind of interesting how inconsistent it is across the board. But for all intents and purposes, this is called flood stage. Anytime we go above a damaging stage point, that's where damages occur, and those are the points we're pulling out. And so we would indiscriminately pull these points out all the time. We put these in a table, and so there would be these crest values for the actual flood events that occurred, and then there were the without projects stages we put in there. We'd hand it off to Econ, and Econ would come back and say, here's your flood damage reduced dollars, like it was magic, right? But it's not really magic. What they're doing is they are looking at a elevation or a stage damage or flow damage curve, and basically correlating whatever crest value we give to them to some type of damage function. So this would be agricultural acreages flooded or crop acreages. And then down here would be like damages, like urban damages or structure damages, if you will. And so these two curves, so Vandalia and Fayetteville, are two damage curves for the watershed of the Kaskaskia River. So the Kaskaskia River is roughly 6,000 drainage square miles. And so there are two damage curves in the legacy system to use to represent that entire watershed. I don't know about everyone else about that square drainage area. That seems like a lot of area for only having two stage damage curves. And so it was interesting. This is one of those points where I was saying that sometimes it's well above flood stage. We would have to get 5 feet above flood stage before this thing kicked in. Flood stage actually here was somewhere around 375. This is actually closer to like 10 feet above flood stage before we even start calculating damages. So 10 feet below is where flood stage is at, which would mean that roads are being flooded, things are starting to get flooded, but we didn't have that captured in these stage damage curves. The other thing is that these stage damage curves, these elevation damage curves, we lost the year that they were built. So we don't even know how to price index these. This was one of the uglinesses that we found as we were starting to upgrade this process. And so these are likely from when the original reservoirs were being built, which is probably the reason why the damages don't start until they're 10 foot above flood stage. Over the years, from the 60s, 70s, and so on, all the way up to modern times, they've been able to encroach upon the floodplain, which means flood stage has been lower than it probably would have been back in the 60s and 70s. That makes sense on why these elevation damage curves are starting out at such a high elevation. So we could modernize this by using FIA. So we are putting FIA into the sequence, and so we are able to do all of our hydrology, do the RAS modeling to produce inundation maps for the observed condition and the without reservoir condition. And so with FIA, we're spatially starting to do point by point. So instead of doing aggregated stage damage curves or flow damage curves, we're now doing it point by point. So now we can start to look at depth over these structures that are in the floodplain, and these depths over these structures with a project might have a certain depth on the structure, and without project or without reservoir, it's going to have another depth on it. And the difference between those two is your flood damage reduced on those structures. So ideally, this with project won't flood the structure at all, and this red one would be flooding the structure. So you see some significant flood damages reduced. Also, a huge thing in St. Louis is agricultural damages. So there are a lot of the area downstream of the reservoirs in St. Louis have agricultural components, and that was something that was really calculated very well at all in the legacy process. And so we run both of those for flood events in St. Louis downstream of the project. So you can see that this table will have structure damages for an event, for example. So you can see with project, there's this structure damage component. Without project, here's your structure damage component. And then you just basically, this is obviously the old language project benefits, but it's flood damage reduced. You just do simple math. This minus this equals flood damage reduced on structures. And what you can notice is the agricultural damages when we do it is very much a large percentage of it. You can see 85 to 86% of the flood damages reduced are very much associated to agricultural damages. This is true for most of the projects in St. Louis. That's where primarily a lot of the flood damage reduced happen. And so in comparison to the legacy system to the modern system of using SWMS, a lot of the benefits throughout St. Louis have increased by a factor of 8 to 10-fold just because of the addition of just adding agricultural damages. And that makes sense because the primary function of water management for, basically April or May all the way through October is keep the river within its banks, because if it gets out of the banks, it floods out agricultural damages or agricultural crops that are out there. So our primary function that we're doing is exactly that. So that is the reason why we wanted to include that in here, and that's not surprising, the reason why our flood damages reduced have increased so dramatically. So this is one application of how SWMS has been implemented within St. Louis, kind of a real-world example. So this just kind of goes towards that SWMS implementation that offices are expected to do. And so just kind of closing this entire series out with this presentation, we have gone through SWMS implementation. We've gone through definitions of really what this is. You're required to exercise these models on a regular basis, use them for decision making. There's some flexibility on how that gets implemented. So think about how this is implemented, how you can leverage these things. This is not a do this the way St. Louis does it or you're not compliant. These are ideas. There's a lot of flexibility in how you can implement SWMS. So take these ideas, make them your own. Please steal them. If you have any questions, feel free to reach out and we will gladly provide any of this information to you guys and how it could apply to your area. So we've gone through basically exactly what we do with the watersheds, monitoring data, watershed conditions, modeling, the reporting. We've talked about the flood forecasting and the how that's utilized out in the field and the differences between the modeling and what real world is. And then we've gone through the flood damage reduced. So we've kind of gone through the breadth of these things. So if you have any questions, feel free to reach out to us and we can easily help you implement this within your office or help you overcome some of those hurdles. If you have any questions about our software, need some help, or are looking for additional training, check out these links. They also can be found in the descriptions below. Thanks for your time.